Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. First of all, let me introduce myself. My name is Nur Ismy Afiah, and my student ID is 21701133. In this presentation, I would like to present my thesis proposal, performance analysis of relay aided on device-to-device communications underlying 5G cellular network. The first topic is background of my thesis is the increasing number of cellular user equipment makes the need for network connectivity usage increase. So this is making the overall traffic at the base station. For solve the problem, we need a technology is called B2D for upgrade and network connectivity in 5G network, which is communication system device to device is the system to allow two or more CUE or cellular user equipment make a communication without going through the base station. But the implement of B2D is still not optimal for solve overload traffic from the effect too much user. So we propose device addition. In this thesis, propose relay aided or RA in uplink communication with addition of a relay node RN device. The second topic is purpose and benefit. The purpose of this thesis is to determine the most optimal technique in overcoming the transmission system in B2D, using the decode and forward relay aided B2D technique with the relay aided scheme to increase the capacity and range of the transmission system. And the benefit of this thesis is knowing the two-way DFFAD2D working system in underlying mode. And the second is provide reference for the best transmission techniques in overcoming traffic capacity and transmission system coverage. And the last is provide reference to new technologies being developed. The third topic is scope of the problem. The first scope is in one cell, there are two types of users, namely CUE and B2D. The second is the protocol used is decode and forward OTR. And the third scope is the algorithm used is an iterative algorithm. And then the communication scheme used is half duplex or HD, full duplex or FD, and relay aided RA mode. And the last, the frequency used is 2.6 gigahertz. The next topic is system overview. The system overview of B2D will display on my presentation. In generally, there are a base station between CU and CU for make a communication, but in B2B system, we don't need a base station between DU and DU can make a communication. And then the system model design. This is a picture with a model design of my thesis, which is the system model which consists of the one B2D pair there is DU1 and DU2, and there is one cellular user, CU, and one base station or BS or E node B. D2D pairs communicate with each other using the same uplink type in allocating frequency and time resource to the CU. This creates some mutual interference between the mobile link and the D2D link as shown in the picture. When providing uplink resource, D2D communication interference will only affect the BS. This interference can be reduced through coordination on the BS. In the second time, slot communicate using the downlink side of the relay to DU1 and DU2. In relay-aided mode, as an additional terminal, a relay node is added between DU1 and DU2, shown in the figure to assist and improve D2D communication against interference. Achieving optimal D2D operation requires a system that maximizes the transmission rate of D2D communication, generally obtained through control of transmit power on the transmission side for D2D user according to the quality of service QoS requirements of the CU, I mean. And the next topic is flowchart simulation of my thesis. First of all, start and then initialization, and then user deployment, and then thin air calculation, and then solution analytics, and then allocation algorithm. After allocation algorithm, result analytics, and after result analytics, suitable result, which is in suitable result can make a true condition. The first condition is no suitable result, we back to user deployment, and second condition, yes, suitable result, we can make a conclusion, and the last is finish. Maybe that's all about my presentation thesis proposal. Thanks for the attention. Wassalamualaikum warahmatullahi wabarakatuh.